Yep. Good morning, everyone. So we are from the team one for the graduation project two, and the project name is face recognition of US presidents using the machine learning. We have a team of 8 people. So the team members are Harika, Ramya, Nachket, Krishna, Pavan, Rakesh, uh, Chandrakant, and Priyanka. So coming for the slide, so we are currently the second slide deals is the discussion with the abstract and introduction of the face recognition. So here face recognition uses the image processing becomes a popular model nowadays, and it has been used in many applications such as a criminal identification, face unlocking systems in the mobiles, and even in the office security system. High speed GPUs, UPS has spearheaded the research towards the design of image processing model for various purposes. Image processing systems use either offline data or a real-time images to predict, classify, and detect the objects. In this project, a face recognition system is developed using the YOLO machine learning model. So here it uses the dataset. Dataset is divided into training as well as the testing dataset. So training dataset will be the 80% accuracy, and the whereas the testing dataset accuracy is 20%. And this project is built on a machine learning model for picture testing as well as the specification. This model will accept a photography of US president and specifies the president names in the image as well as a demonstration confidence in the accuracy of the outcome. The version 5 of the YOLO model is being used in this face recognition, which defines the region in the image that is made to detect in order to determine the president's name. So the face of a person is also trained the model, and the data which has been sent to the model is in the format of .txt format, and the photos will be annotated and also feed to the model. This model will analyze an image and determine the president's names. So for this project implementation, we have a couple of tools have been used. So the tools will be discussed by one of my teammates, Harika. Over to Harika. Thank you.
Yeah, to build this application, we use Python language, and to test and train these data sets, we use different types of libraries. One is Tinker, and second one is Detect, and third one is Skyline. So to build application and also integrate development environment, we use Google Colab and also PyCharm Community Edition. So by these language and libraries environment, we are building our application. And next one is explained by Krishna.
Good afternoon, good morning, everyone. So we are going to now discuss about the YOLO model. YOLO model full form is like you look only once model. So it's basically a machine learning model that detects and recognizes various objects in a particular picture, a video, and even in real time. Like we can use this in different areas. So next thing is like YOLO uses features learned by a deep convolutional network, neural network (CNN) to detect a particular object. So object detection is performed as a regression problem, and it provides probabilities for detected classes and objects by drawing a bounding box on them. So basically, a bounding box consists of 5 predictions: X, Y, W, and H. So and confidence as well. So X and Y coordinates represent the box relative to the particular bounds of a grid cell, and and height is represented by W and H, and the confidence represents uh, the percentage in which it can predict like a particular president's name. For example, if we have given an input of Obama, so like it will give a particular confidence, like it can be Obama in 95% confidence or something. And the next part will be continued by my teammate. Thank you.
I think Nachketan in mute.
I'm sorry, it's my concern. Good morning. Like I'm going to discuss about the training part. So after selecting the model, we have to train our data sets, and we have to divide our data sets into two types, like training and testing images. That is like 20% and 80% respectively. YOLO requires a high-speed GPS, and we choose to run on a Google Colapse, which offers a high-speed GPU and CPUs without any installation. The Google Colapse is an online Python interrupt that provides a high-speed GPUs with a zero configurations and a no lag. It allows the execution of the Python code in a browser. So this is a flow. Can you move on to the next slide? This is a flow chart of the project. So first we're going to start with a build model using a machine learning, and then we're going to divide it into two parts like training and testing images and a training. Then training, we need to label the data and train the model. After that, we're going to test it with testing images, and then we're going to return to the stop. That's it. And the next part going to discuss by my friend.
Yeah, thank you, Nachiketan. Yeah, coming to my slide, we are going to see the second flowchart, where we can see here the image data sets and the pre-processing. Sequentially, it is connected to the CNN, where CNN is a convolutional neural network, where it is a neural network in which it is used for image processing, classifications, and segmentation, and other for auto-related correcting the data. And mainly it is used to analyze the visual imaginary that we are going to develop in this project, where in this we can see the object detection and the object tracking, and mainly it depends upon the performance evaluation parameters. We can see it here, where TP, TN are nothing but the true positive, true negative, and false positive and false negative, where these are the two main sections to develop these projects, and these both are connected to the visual surveillance applications. And yeah, we can see the output in the next slide. Yeah. This is the output we are generated in this project. In this, we can see the two images of the jewelry Taylor of 0.54, where in this only the face is recognized with the low recognition images. We can see it here, and the next slide will be continued by my teammates. Just go ahead, please.
And coming to the testing, after training, the YOLO generates the weight file, and that is used for the prediction. And the output was given by the YOLO after running it on the images consists of the bounding boxes. It also draws the bounding box of detecting the objects on the images, and YOLO's given output was different from the required output. So we ran YOLO by using the PyCharm and modified its code to get the required outputs. And the next slide will be continued by one of my friends.
Hi everyone, coming to the implementation, let's see the implementation part. The first we have created the image set libraries. Let me show you the first we have created the image sets, all the president's images. We have gathered almost 200 images of the US presidents. In the next step, we have labeled the images one by one using the makesense.ai. Then by using the Google Colab, we used the YOLO v5 model to train all the data sets, the images in this data set. Then we have written a Python code in which it contains all these files. Some of the important folders are, this is the constant.py, in which the constants, the variables we used in this main.py and loss.pt was declared here. Next, in the detect.py, it is also a default file which is used to display the results in the console. Now I'm going to execute the code. Let me run the code. Yes, after running the code, this is the user interface we used to get. Now we have to select the images from this library set. So I'm going to hit select. I'm going to select my image library. After selecting the folder, then we used to select the predict. Next, the output will be continued by my teammate.
Coming to the output, as we have seen after running the program, this is the output that is being generated with the name of the presidents and with the percentage of the confidence. The percentage of confidence is nothing but the accuracy of the image with which the model it is saying the name of the president, which is there already there in the image. So if we can see right now, our model can generate around 50 to 95% of confidence. That is fairly good, because some of the images have low intensity light, and some images are very clear, in which we can see the facial features very good, so that the model can capture the features and give the prediction with some 95% confidence or above 90% confidence. And going on to the next thing, open slide once. So these are the input images that we used to get the name of the presidents. If we can see, some of the images are very clear and some of the images are not clear. So when the images are clear, you can get the confidence around 90 plus, and if the images are not clear, you can get around 80 to 85. If we go on to the next thing, this is one of the screenshot of the images. This is one of the screenshot of the output. So in this output, we have tested 18 images, and the average accuracy is of about 87.71. So if you can see the confidence level over, for some images it is 0.8, for some images it is 0.93, and for some images it is 0.77. It depends on the image resolution. And coming to the next discussion thing, we have trained our model using large number of residence images using the deep CNN approach, convolutional neural networks, in which we have captured the facial features of some of the presidents in the training data set, and we have recognized those in the testing data set. We divided our data set into training and testing, and we concluded the accuracy of face recognition on high resolution images is higher, and the low resolution images lower. The face recognition tends to do false recognition when the image is of low resolution, because if there is no light or the images with low resolution, the model can mismatch features of some president with another president. So it becomes lower. Therefore, the accuracy of a model on high resolution images is between 90 to 95%. That is fairly good for a machine learning project to predict. And on low recognition images, it is around 80 to 85%, because of the light and the facial features, we could not capture many things. And coming to the next, and this is the data. In the data set, we have like so many types of images, which is having low resolution, high resolution, and images which are pretty good, not too bad and not too bad, not too good. And the low resolution image, the least accuracy we got was around 55% of the accuracy, and with high resolution images we got around 60 to 80% of the accuracy, and with normal good resolution and which are having very clear thing, we got around 90 to 95% accuracy. This was the accuracy of our model we have written, and the next thing will be taken care by my friend.
Yeah, thank you, Chandu. Coming to the conclusion, we had a total almost of 1,000 photos, and we used 800 of them to train the algorithm, and we tested the the trained algorithm using the remaining 200 photos, and determined with a designated system is providing on an accuracy of almost 93% and almost same learning rate as well. And YOLO is a great algorithm because when an image is passed to it, it reaches the exact point on the image on which basis the decision is made. For example, in our YOLO is look for the facial features, etc. And coming to the next slide, here are the references. And for the image-based face detection and recognition, we used Faizan Ahmad and Ayman Nazam and Jishan Ahmad. And for the classification model based on deep convolution neural network, we used Huiyan Xin and Yong Wang 2019. And for face recognition and identification, we used deep approach of 5th International Conference on Electronic Design. Thank you for giving this opportunity.
Thank you, team.
Thank you.